Okay, so let me, introduce our keynote speaker. Today's keynote speaker is Professor Yelena Yesha. She is a distinguished university professor at the Department of Computer Science and Electrical Engineering at the University of Maryland, Baltimore County. She's also the director of National Science Foundation Center for Accelerated Real-Time Analytics, CARDA, and she received her bachelor's degree in computer science and in applied mathematics from York University, Toronto, Canada, in 1984, and then master's degree and PhD degree in computer science from Ohio State. From early 1994 to 1999, she served as the director of the Center of Excellence in Space Data and Information Sciences at NASA. And her research interests are in the areas of distributed databases and distributed systems, mobile computing, digital libraries, electronic commerce, and trusted information systems, and many other areas. And she has published 11 books as author or editor and more than 200 papers in prestigious refereed journals and refereed conference proceedings. And she has been awarded external funding in total amount exceeding $40 million. So today, she's currently working with leading industrial companies and government agencies on new innovative technology in the areas of cybersecurity and big data analytics, with applications to electronic commerce and climate change and health. And she's a fellow of the IBM Center for Advanced Studies. So without further ado, I will give a floor to our keynote speaker, Dr. Yelena Yesha. Thank you.
Good morning, everyone. Thank you for a nice introduction. On behalf of myself and my colleagues at Carta Center, I would like to thank you for this invitation and opportunity to share with you some exciting results. Today I'll be talking about the use of blockchain to power digital government, and specifically my talk will be organized in the following fashion. First of all, I'll motivate why blockchains. Why do we need blockchains in the government or in general? Why is this new emerging transformative technology gaining so much popularity? And what is it all about and how we can actually take advantage of this? I'll be talking about different types of blockchain solutions that nowadays available. Then I'll spend quite a bit of time discussing how these different blockchain solutions are actually finding its application in different government settings across the globe. And then towards the end of my talk, I would present an innovative solution that was actually developed at Carta at the centers that I'm heading, which enabled to solve certain problems, and also give you a flavor about the implementation of this innovative solution as it finds its way to the US federal government, in Department of Homeland Security and National Institute of Standards and Technology. So going back to the main topic of my presentation, why blockchains? Why nowadays blockchain area getting so much attention in academia and especially in commercial labs? As the amount of information explodes and we have growing lists of digital records, we need to provide a certain way of governing this data from the security and consensus perspective, but we also want to have a means of providing a shared information sharing without compromising the actual performance of the system. Not just we want to accomplish all these goals, we want to accomplish all of this in decentralized network environment, and also enable real-time or close to real-time transacting against this huge information base that is being created and growing as we speak. So what is blockchains? In general, blockchains can be kind of defined or split into two types. So one of them that probably everybody think about and gain much more popularity, at least in literature, are known as permissionless blockchains. So they gained popularity more than a decade ago with the conception of cryptocurrency, like Bitcoin, Ethereum is a kind of household names, everybody understand it. And since it's permissionless, it's also enable everyone to participate. So anyone who would like to participate can actually participate. that gives it kind of an open marketplace, if you will, for being able to create your own coins. You probably hear a lot of stories about people mining their own coins and being successful at the beginning, and then making quite a bit of money and things of that nature. So these are the situations which require computational kind of resources that enable you to perform this type of tasks. And also, they're also vulnerable to the power attack, meaning they're not very secure in nature. So the other type of blockchains is nowadays gaining much more popularity in the commercial implementation, in the situations where actually you need to solve certain specific problems, and I'll address those use cases later on in my talk, where you would actually need to power certain specific verticals by blockchains and take advantage of their power. So permission blockchains, the good example would be Hyperledger, that was primarily developed by IBM as an open source. I'll also talk about Kaios, the system that we've developed, and now currently it's getting tractions and adoption in government as well as medical device industry. In this type of environment where we have permission blockchains, everybody pretty much needs to know the identity of each other, but no one needs to be trusted. So in a sense, we have a full idea or information about the participants, but it doesn't mean that we know them, that we actually trust them. And these models are usually built on so-called threshold adversary model. It means that it will tolerate one-third failures in the system. So they're very much fault tolerant. Now, if we try to analyze the design of the respective blockchains, we can kind of design or think about a layered view, where we have layer one, which would be state machine replication, where we have proof of work for permissionless blockchains, and we would build our permission blockchain on the so-called Byzantine fault tolerance algorithms that would create a base for its implementation. Now, the layer two would be smart contracts, and probably everybody by now heard this term, and smart contracts actually mean different things for different people, but it has specific meaning in the environment where we are deploying a blockchain solution. So what it does in this type of environment, when we build smart contracts on the existing blockchain solution, it would allow to programmatically facilitate, verify, or inform the negotiation or performance of a business transaction. So in a sense, we can real-time understand and validate the users, the consumer, let's say, and provider in case of electronic commerce. We can streamline transactions, but moreover, we are able to provide an extra layer of cybersecurity that enable the users actually feel much more comfortable with this type of environment. And layer three is the most exciting layer because it provides services, right? So blockchains primarily powers what we call nowadays a service economy. And I'll give you kind of a big landscape where exactly which applications are taking the biggest advantage from this type of transformative technology. So some people may ask, why blockchain, why not simply cloud, right? So in certain instances, cloud solutions probably would serve the same purpose. In case of cloud solution, and I'm sure most of the listeners here, the participants familiar with the cloud, in the cloud environment, we have single party of trust, we have single point of failure, and this type of environment usually violates the three major security goals: confidentiality, availability, and integrity. Now, the conventional blockchain solution can provide both availability and integrity in presence of arbitrary failures, which gives us basically a much better fault tolerant solutions than cloud, as well as much more secure solution. And later, when I'll be talking about an innovative solution that we've developed and are commercializing, it actually also provides a better performance in the system. So the question is, why not existing permissions blockchain? So what is missing from the technological perspective in today's open source or proprietary system that is available in the market? There are certain specific technical aspects that are not simply present in the existing permission blockchain. There is no publish subscribe messaging pattern, like read-write, for example, which is extremely important, especially important in the area of Internet of Things, Internet of Medical Devices, where this type of things are very, very important and basically done on a millisecond basis. There is also no confidentiality or cryptographic access control. So to implement confidentiality and access control is very difficult in the existing environment. And then of course, once we are talking about trusted execution environments, it would require a single trusted vendor, which is by itself create another level of potential failures in the system. And there is no modularity. So in a sense, the way these current commercial systems are developed, there is no one size fits all blockchain. So in a sense, we can argue that the existing solution fits certain class of problems rather than being able to be modular in design and enable basically customize the platform technology to different application depending on the need of the consumer or the other organization who is taking advantage of this technology. Now, since we are talking here primarily about the blockchains in the government, the next 5-6 slides will kind of concentrate on the application. Now that we set the stage, why blockchains, we kind of define them, talk about their functionality and ability to solve certain unique problems. Let's talk a little bit what is the state of the art, where we are, what kind of applications are actually being powered as we speak in different parts of the world, and then talk a little bit about the experience from these countries and individual companies, and see what works, what doesn't work, and what are the current challenges. So as I said, a blockchain is usually viewed as a layered approach. So let's start with the most exciting layer, at least to my taste, the application layer. So here, the first applications actually of blockchains around the world came from financial markets. Even though financial institutions are known to be the most conservative because for obvious reasons, because they keep people's money and the things are very vulnerable, still financial institutions realize that blockchains is transformative technology that they cannot afford not to play with, if you will. So the good example, of successful example of using blockchains in financial market is Philippines bank system. They've been very successful there. Supply chain is one of the best applications of blockchains, and they're successfully being deployed in Walmart, IBM, Food Supply Initiative, and many others in pharmaceutical industry, and also in the government in Defense Logistic Agency. They're using supply chain with optimization for actually moving critical supplies. For example, now we are living in the realm of global pandemics. Then the many traditional supply chains got disrupted because of coronavirus. However, at the same time, we are not necessarily do business as usual because we want to prioritize certain supplies, certain critical supplies, like medical supplies, like food. What we need is some optimization functions and ability on the fly, real time, reorganize our existing supply chain to fit the demand and needs at the global scale. And blockchains in this environment is very well suited to address these issues. Lots of applications to biomedical and healthcare. The Department of Health and Human Services using this technology to actually early diagnose sepsis. Then we are working with FDA trying to see how we can streamline the information that comes from embeddable medical devices and all kind of exciting things, not just from the point of clinical trials, but also from the point of view of public safety. In case devices would fail, how would you inform the public in a very responsive fashion, and things of that nature. And of course, critical infrastructure. So smart meters, smart sensors, electric grids. All of these can be nicely secured using the blockchain solution. We had some experience working with Department of Energy in US, And there they implemented the largest it was the biggest blockchain implementation, at least in the US federal government. And we learned quite a bit from the people who were working on this. Layer 2, as I mentioned, are smart contracts. The examples of commercial implementation is Ethereum virtual machine, Hyperledger chain code. Now, they all are commercially available. Many of them are open source, but a number of them, again, have certain shortcomings from the technical perspective. They're not able to cover or capture all the necessary technological activities that we would like to. So we'll be talking a little bit more when we talk about innovation and challenges about the smart contracts a little bit later in my talk. So in terms of layer to provide us consensus, we are kind of advocating in the government environment the solution using Byzantine fault tolerance, which require low energy costs, low latency, and immediate finality. Then the other one, which is permissionless, is pretty much based more on point of work, high energy, no immediate finality, allow anybody to join. There's a proof of something like proof of elapsed time. And then recently, more and more, we see implementation where you have hybrid proof of work, where you have basically a combination of two approaches. And the reason we are seeing more and more hybrid kind of approaches, because nowadays the organizations are not, those that adopted one or the other blockchain solution, not necessarily willing to move to another implementation. They rather want to augment what they have. So the key component here is interoperability. So if we can design the new generation of blockchains with modularity and interoperability in mind, we can use certain components, innovative components, to add on to existing solution. And this type of environment we usually call hybrid environment, where we will basically use permissionless blockchain or a combination of different solutions to address specific application problem. So again, in terms of categories, we already discussed that. We have permissioned blockchain, where participants have to know the identities of each other, permissionless, anybody can join, and then combination of both, which we call hybrid. So permissionless system, again, this is one of those systems that gained the most popularity and probably the most famous. They're the first kind of arrived to the market, and they found their applications in the area of cryptocurrency, and that's how it happened. So Bitcoin, Ethereum, and then Ethereum POS, hybrid consensus, hyperledgers, and POA network. These are all examples of what currently exists. And then, of course, you have Facebook, who developed Libra, which is their own cryptocurrency that built on partially open, partially proprietary blockchain solution to the Facebook. Okay, this is probably the most kind of exciting slide from the perspective of digital government. So what is happening around the world, right? So as we are living in a global environment and the environment becomes more and more global, what is happening in terms of adoption of this technology? As we all read the current statistics, the claim is that by the year 2030, 10% of global economy will be powered by blockchain application. This is huge, right? So which countries are ahead and who is adopting what for what purpose? So in terms of use cases, what is happening now? There are a lot of cases in medical and healthcare where China, US, Switzerland, Philippines, Japan, Brazil, and others are taking advantage of supply chain, Internet of Things, and Internet of Medical Devices. And this is where they're using blockchain to power this type of application. Now, financial markets are one of the early adopters as well. This is pretty much most of the countries, if not all, are looking at cryptocurrency, asset management, and trying to understand what does it mean to have cryptocurrency in local and global economy, and how it can facilitate or disrupt the existing economic activities and basically exchanges of the information. Critical infrastructure, I think I already mentioned that. How do we protect our electric grids, national resources? How do you do asset management? How do you do optimization? So South Korea is leading the way in this arena in terms of implementation. There is a lot of work going on in the arena of smart cities. However, many smart cities are powered, if you will, by the blockchain technology, which use cryptocurrency and data management. Then asset management is another place where Georgia, Sweden, and Switzerland is taking advantage of this. And this is primarily in the area of real estate transaction. So the claim is that in the next few years, the concept of face-to-face closing, many of you probably bought your first, second, whatever house, piece of land. You had to go through, pretty elaborate process with a lot of paperwork. Now we're going to have smart contracts, and all these activities would be totally automated. And it's not just auto industry, but also insurance industry would be automated in a very similar fashion, where again, blockchains will be the backbone of this system that would enable this type of optimization in the system. Education, Japan and Malta would allow certificate management, data management, Philippines and Australia will do cloud data management and other data management, or sometimes in the area of blockchain, we call data management, in fact, data governors, because using the blockchain, we can pretty much control real time who has access to what and what is happening there. Now, energy sector, which is a very important sector in each and every country, also got a lot of interest in the area of blockchains, or the blockchain usage, I should say. And as you all know, there is a lot of energy trading. We have a lot of commodity trading through the transaction management, and it benefits real-time and peer-to-peer exchange. Then we have smart energy, where you have smart meters, and that would require resource management, but also require a certain degree of cybersecurity to make sure there is no foul play or physical interruption of system. And then, of course, we have system protection, which we call SCADA, which is a government-regulated system, which does data and service protection. And the benefits, of course, here are intrusion tolerance. So what are the challenges and consideration? First of all, adoption challenges. It's a new transformative technology that requires kind of adoption that would not be just financial investment, but also training investment, and also understanding the transformative concept. So industry is getting closer to adopting this type of technology, but we still have a big learning curve in terms of actually making sure that we understand fully what type of blockchain solution to use and how exactly it will impact certain specific use cases or vertical markets. The other problem is data quality, which is very difficult to control, because we have to deal with the data, or basically analyze the data as it comes to us. But as we all know from our early days in computer science, garbage in, garbage out. So if we don't have a good quality data that we are ingesting into our system, it's very difficult to produce, or sometimes impossible, any valuable or effective results from any applications or computations that we are doing. And then, of course, correctness and security of the system. How do you stress test the system? How you make sure that the system actually delivers what we expect it to deliver? On the technical challenges side, the biggest problem that I believe we were able to address in our solution is the performance trade-off and blockchain standards. So the performance trade-offs are huge. If you look today, relatively the most known solution, which is a Hyperledger solution led by IBM, it has its own significant challenges in terms of the performance. So that's one of the biggest problems we have. Now, in terms of blockchain standards, the governments of the world are working together on creating some, at least working standards. US government is working on the standards, but we don't have a fully adopted standards that we can refer to, and that can be a downside to actual adaptation of different blockchain solutions in immediate future. Scalability is an issue. Then, of course, privacy and compliance. Now, speaking of the government, at least in US government, all the implementation is supposed to be FISMA compliant and has to go through rigorous process of being vetted inside the federal government. And this is time consuming, resource consuming, but also requires an access to the knowledge expertise that would enable things to move forward. And then, of course, timing assumption, how long it will take to implement and what does it mean. I know I'm almost out of time, but in the next maybe 5-10 minutes, if you guys allow me, I want just very briefly to share with you Kaias, which is a next generation permission blockchain that was developed in the center that I'm heading, and I'm one of the inventors. We have 2 pending patents on this, and we've got a number of innovation awards. We got Maryland Innovation Initiative Award, all 3 phases. We also were the first recipient in the history of NSF or Fundamental Innovation Award last year. And this work is also heavily funded by Department of Homeland Security. Let me just give you at least a very high level overview of what we were able to achieve in this system. So this is kind of Kaias overview. It's a full-blown system. Actually, now it's already in the product stage. Here is the overview. It's a modular design. It has about more than 30 configuration. It has rich set of functions. The functions that I mentioned before that are absent from commercial systems, we were able to capture in this type of implementation. We have publish, subscribe, fine-grained, decentralized access control, private smart contract. It has phenomenal performance. It's actually, we compare our performance with IBM bare metal setup, and we're about 5-6 times ahead of in terms of the performance. And the applications currently we are looking at now and deploying our solution is Internet of Things, supply chain, and health IT. This is basically a module design of our system that gives you an overview of how it works. Again, one of the most advanced features is publish subscribe feature. So far conventional blockchains don't have it, but we were able to implement it effectively in our solution. The other interesting feature here is fine-grained access control. If you look at the conventional blockchain solution like non-cryptographic access control, trusted execution environments require a single trusted vendor. So here we offer decentralized confidentiality and fine-grained access control. Now the clients own the data and decide who and when the data can be accessed. Different people can have different access classifications. So what it does in a nutshell, it allows what I call assured information sharing. So different parties to the system have different type of access to different type of data sets, which is fully decentralized and fine-grained in nature. Of course, privacy is a big thing, especially in the healthcare. So not many applications that do need privacy. So users need to protect their data. Government agencies and companies do not want to share databases. They have proprietary databases. But at the same time, in order to perform certain applications, we need to have an access to the database without sometimes, reading everything or to a specific kind of records, like patient record exchange. There are more and more exchanges, so those of you that are in healthcare know, coming at the state level. So how do you exchange information without compromising the privacy of individual patient? Then Internet of Things is gaining tremendous popularity around the world, and then you would like to protect the communication, as well as you want to protect the data that is coming to and from the devices, and then of course supply chain optimization. Now, in terms of Kaias performance, we have scalability. If you, again, compare this system to the conventional blockchain, it can handle conventional blockchains can handle a few thousand transactions per second. They're not scalable in application with large volume of data. And it has a very heavy client-end library. In our situation, we have a very light client library, only requires a few scripts to run on almost all chip devices like Raspberry Pis. Throughput is an order of magnitude faster than existing solution, and also supports a scale-out architecture. What we mean by that, we can add certain modules without actually compromising the code and the existing kind of backbone platform architecture. And finally, I want to share with you good news that our solution found its way into US government implementation under cooperative research agreement between the University of Maryland, Baltimore County, the Department of Homeland Security, and NIST. We are implementing Kaya's solution in the federal government to actually optimize the supply chain of software licenses. So that's the kind of the trial case that we have. Okay, I'm out of time. Thank you so much again for invitation. And now I guess we can open the floor for questions.
Thank you very much, Yelena. That was a very, detailed, presentation on the blockchain. So, is there anybody who wants to speak to Yelena? Any questions? So, I have a quick question. So, you mentioned, oh yeah. Long, you
okay.
like to go
so
ahead?
You
okay.
First. No,
you go ahead, please. Yeah.
Okay, thank you. I'm interested in that to exchange or share the information about health information, healthcare. How can a patient, I myself, share my data with some hospital or with some doctor? Is the blockchain deliver that kind of services?
Yes, absolutely. I think that there is ingestion mode, which can be command line or a simple interface where the patients actually can interact with the underlying data warehouse. But this warehouse is governed by different blockchain. And in our case, it's Kaya's, but it can be anything you think is appropriate for your solution. So definitely in the healthcare arena, blockchains are very good and provide privacy for individual patients. I kind of paid more attention during my presentation on communication between different exchanges and maybe the kind of, if you will, what you call in business to business solution. But here, patient as a customer has the same rights, and giving the fully decentralized nature of application. It's very easy in real time. You can input the information into the existing data warehouse and provide privacy and confidentiality as well.
So if it means I, as a patient, I could join the blockchain, or I just upload my data and into a data set of maybe hospital, and the hospital just could be a node of the blockchain.
Correct.
Mm-hmm. That's right. Yeah.
Right. But hospitals have to agree to be part. Hospitals should agree that they are governed by blockchain. So once the hospital adopts certain blockchain and they'll decide which one the most appropriate, then definitely you can build a very simple interface for the individual patients. In fact, we're having a pilot project that we're doing exactly that. We're working with individual patients, especially given corona situation, that are immune compromised, can't leave their house, but they need to do clinical trials or need to do certain sophisticated gathering of their medical information, and they're able to do it from their iPhone, or they're able to do it through the command lines, through the computer, very, very effectively and transparently.
Okay, thank you. Thank you very much.
Thank you for your question. Okay, I have a quick question if there is nobody else. Anybody else?
I have a question, but I can follow after you.
No, please go ahead. Go ahead, please, because I'm the.
Oh, thank you. Thank you very much for the very interesting presentation. It was very intriguing to hear how much experience you have with blockchain. I was also very interested about your examples on use of blockchain in supply chains and also with the Homeland Security pilot.
Right.
The reason I'm interested is we've been involved in a lot of projects in international trade where we work with customs organizations. So we are looking at the interplay between, let's say, the business supply chains and the government. And we were also involved with TradeLens. That's one of the blockchain platforms that was recently launched by IBM and Maersk.
Right.
And what's very interesting is that in one of the projects where we are working now, the government is looking into these supply chain initiatives. and how to use this supply chain data, different, let's say, platforms, but also to set up their own blockchain platform. So indeed, you mentioned interoperability among blockchain platforms, also, especially also privacy, because some of the issues that you are mentioning, you don't want to see everybody's data when it comes to customs. It's very, so do you have any experience about setting, because if a government needs to deal with a lot of different platforms, they need to set up some kind of standards or some way to interact with these, and to, do you have any experience where there's some initiatives were able to set up such agreements, or what was the way that they
Well,
deal?
I think, okay, so NIST is working on the actual standards, and they're not, to my knowledge, are not available yet. However, just to shed a light on what you're saying, in US, and I cannot speak of other countries, the systems that interoperate with government data need to be FISMA compliant, meaning they have to be government compliant and meet all requirements and standardization. So in case of hybrid implementation that you're mentioning, perhaps the hybrid solution and individual components will have to go through the FISMA compliance before they will actually go live, if you will, in terms of they actually using them for the implementation. In the Department of Homeland Security, we had the entire day dedicated to our innovation, and we had actually Director of Customs from Homeland Security there, and he's extremely interested in what we do. And customs is a big problem, and from a number of reasons. It's not just for the supply chain, but also counterfeits. There is a lot of counterfeit products that are entering through the ports, through different customs places, and things of that nature. So I don't think this problem is solved. They're at the tip, and while they're looking at blockchain solution, again, to the best of my knowledge, there is no adoption as yet. And we are hoping what we are doing with Homeland Security here for software licenses, and once we get it FISMA compliant, we may be able to do a pilot, again, internal pilot, to look at also at the border security as well, and try to combine it with number of other systems. There is a border security for counterfeits, but there is also border security from homeland protection, which is also very, very significant. Now, this type of implementation usually calls for intelligent modules that would sit on top. So more and more we find situations where blockchain are powering the governance and security of the data, but they would require machine learning or some deep learning algorithms and or optimization that would sit on top. And so we did develop in our solution several modules that actually enable us to provide the complete solution. So, because if you strictly look at blockchains, for the most part, it's a platform technology that powers certain application. It doesn't do application, but if you want to provide solution, not just support application, then you need to have the optimization routines that nicely interoperate or become complementary to the platform technology.
Thank you. Thank you very much. Thank you very much for the question too. It's very relevant. Yeah, who else?
Yes, I have like a quick follow-up question to this one, because so can you please extend a little bit more how an application on supply chain of blockchain looks like? For example, you were mentioning this software optimization for the U.S. government. So what is exactly the meaning of that? Just to help me understand better.
Okay, I think I understand your question. So what I mentioned is that in the current situation of global pandemics, you usually, first of all, let's kind of backtrack and say that the US government and most of the modern countries in the world have very kind of optimized and pretty much real-time good working routines for supply chain, because people, supermarkets are filled with food, you know, people get what they need for the most part, again, in the advanced countries, so we don't have a problem in supply chain. The problem arises in two fashions. It arises in the fashion where you have disruption of supply chain. Like, for example, suddenly we needed a lot of medical supplies like masks, ventilators. And then again, the usual flow of this type of critical resource was either uniform or was adhered to certain specific algorithms. Now, all of a sudden, New York, New Jersey, as we know, initially were in the most dire crisis. So how you real-time re-optimize your supply chain without compromising privacy, security, and also enable this type of optimization of the critical supplies. This would be one way of doing things. Yeah. The other thing is, it turns out, and we talked to General Service Administration and the government, that US government is overbuying software licenses, because every agency buying their own Oracle license or whatever license, but they're not necessarily using it. So the question is, how can we use blockchains to do this assured information sharing, so the agencies, since they're all federal government, can share this information, and then the savings in terms of the resources is enormous. We're talking about tens and tens of millions of dollars and maybe even more. So that's another example where you would streamline the data and make it available. You'll have their reproducibility, but also you'll have the original source. You'll know who bought what, right? Because otherwise every agency has its own database. They're all compliant with their own requirements, but they are not necessarily have a global picture from the, let's say, Office of Management and Budget perspective, who bought how many licenses and didn't use them. So then, of course, you can reallocate this and use licenses to some other agency and save government tons of money. So this is one of those things where this can be done. In the healthcare, what Health and Human Services is doing in terms of their prototype, they're trying to use blockchain with some optimization to detect early signs of sepsis, because sepsis is one of the leading cause of death, by the way, in emergency rooms. Because people come, they get their procedure, they get infected, but people don't know, or doctors not immediately understand or being able to diagnose them with sepsis, and when they do, it's already too late. So, and some people even getting discharged and come back with hospitalization, huge medical bills. So how can we optimize the diagnostic part of healthcare that would, in a sense, lead towards modernization of healthcare, but also take medical economics into consideration, where we would provide higher quality of care at a reduced cost. So potentially the proper blockchain implementation can play a significant role in this type of environment. Because remember, the healthcare is about 20% of gross domestic product of our country. It's almost as big as defense. And some people claim that it's maybe a little bit even bigger than defense. So it's unsustainable. The growth of the cost is unsustainable. So we need to do something. And I truly believe that modernization of healthcare will come from the IT, not necessarily just from blockchain, but blockchains would be, I would say, an integral part of modernizing the current healthcare system.
Thank you.
Thank you. Thank you. So you're really talking about integrating blockchain into all these other technologies, right?
Right. You can view a blockchain as being powered by, it's like, you know, when you do certain application, like you don't know whether it's Oracle or Sybase or whatever the database. So the same thing with the blockchain. It's a white label solution that powers a lot of different applications and optimizations.
Thank you.
Any other questions? Thank you very much. Okay, so I have a quick question on the smart contract. So as you said, it's an optimized situation where we have a sort of how to interact with them is sort of fixed. However, there are many cases that if let's say this blockchain is launched for the citizen services, there will be a lot of personalization or customization of certain features when we are executing this one. In that case, would this be possible to be, automated as efficiently as current government between governments? Yeah, yes, that the thing can be very standardized interface, and it can be contract be written. However, if it needs a lot of customization, would it be scalable?
Well, I think when you do customization, you don't necessarily customize the platform. So again, blockchain is a platform, so you don't customize Oracle and Sybase. you customize the application. So you would have to build certain glues or layers that will know the ontology of existing application. If it's in industry, financial, or healthcare, you may even decide to choose different type of blockchain depending on the application. Customization would be driven by the content of the data and the amount of data. As I said in my presentation, you know, if you have large volumes of data, then perhaps scalability and throughput becomes more important than other features in the system. If you do a lot of sharing, it's important. If you need some more lightweight software for IoT type of application, then things have different flavor.
Okay, thank you.
Sure.
Any other questions? I have one more quick question. Okay, so as you mentioned, this, you know, it looks like the blockchain architecture or system. Does this have to be installed in all the partners, you know, place, or would it be more in one place and then everybody's using that as
fully decentralized? So you assume the instance running on every side. It's
okay.
More kind of adhering to your traditional distributed database solution.
In that case, you know, when one node goes off, let's say got failed, and being notified, that verification problem of all the transactions, would it be affected in a whole system, or would it be delayed for that particular?
Well, actually, it tolerates a sort of the failures because it's Byzantine fault tolerant. And unlike distributed databases where you have a big consistency in case of replication, in this case, it's a full consistency, even in the event of a sort of nodes being, we call them clients actually, no, nodes are clients, would fail, you can still maintain real-time consistency of the data.
Thank you very much. Any other questions?
Maybe one more question on my side.
Sure.
You mentioned about your new method where you overcome some of the limitations and you have published, subscribed, and more, let's say, sophisticated access control. Can you please elaborate a little bit on that? Because that's very interesting. It opens new possibilities for blockchain, I think.
Absolutely. Well, it's a patent pending technology. We actually spin off a company out of this, but we have certain papers that we open up and actually submitted for publication. So Soon has my email. If you write to me, I'll be happy to share with you, because I think it probably, to describe it properly, we'll need like a half an hour and a whiteboard.
Yeah.
It's rather involved kind of implementation. So, but I'll be more than happy to share with you the recent paper.
That will be very nice. So whatever you could share on this topic would be very relevant. Thank you.
Thank you. Any other questions? Okay. And I would like to congratulate to you and your team at CARTA, the CHAOS, being, being adopted by the U.S. government, and hopefully you have a great success with that. And then,
thank you.
Yeah, and thank you very much for taking your time, valuable time, to to present this interesting key technology that might be the central for the 5th generation industrial revolution. So thank you very much one more time, and we hope to see you very soon again.
Yeah, hope to see you guys in person.
Okay, thank you very much.
Everyone, stay safe.
Thank
Bye-bye.
you.
Thank you. Bye-bye.